Okay, welcome to your study guide for section 7.3. By the way, these study guides are not meant to be done without first looking at the sources of information. A lot of the information you'll need for this one will come probably from you taking stuff you already know and perhaps thinking about it. If you don't have a copy of your periodic table, you probably should get one of those. I'm not going to do this whole thing for you, but I thought it might speed up the process if we just work through at least part of it, right? So this is a periodic table. I'm going to put my name in there because, hey, Bobby always likes to put his name on things, right? So you've read page 214, right? And so you should be able to answer the following question. You're looking at the periodic table. Which color on that periodic table is going to represent the metals? I'm thinking metals are found towards the left, right? So I'm going to click on blue. Let's see what happens. Sweet, an excellent start. Bobby's doing well. Which color on the periodic table would represent the nonmetals? So now we're looking at the opposite side of the periodic table, the right side. These are the nonmetals, and then of course these would be the metalloids along the zigzag line. So I'm a bright one, I am. Different looking periodic table. Somewhere along the line here you are supposed to be becoming familiar with the names of some of the families. The families are these vertical groups, and again, not all vertical groups, and again they run from 1 to 18, actually have names. But chlorine, gotta find it first, right there, happens to be a halogen. So is fluorine, bromine, iodine, and astatine. I'm going to click on halogen, and I'm correct. Magnesium, what would magnesium be? I'm thinking magnesium, and here it is right over here next to the alkali metals. It's an alkaline earth metal. Sodium, alkali metal. Going to leave a few of these for you to do because it's good for you, right? Okay, let's look at the little boxes you see on your periodic table. And again, depending on which periodic table you have, you may not see this information arranged in exactly the format that's shown here. But this is the element lithium, the name. Below it, top left would be the atomic number. This would be its common ion charge, and then this should be, let's check another periodic table, lithium, is its atomic mass. On this particular periodic table, this is the density. So the atomic number of silver, which one of these is silver? That one is, what do you think? We're going for 47. Uh-oh. You know what I did wrong there? Bobby put it in the wrong box. So the atomic number of silver is 47. Right. Just in case you wonder, we missed number 1, the atomic mass of lithium to the nearest whole number. And that's a very important point here. You've got to round these off. Lithium 6.94. If you round that off to 7, of course it's locked. I'm going to reset that. 7. Boom. Amazing. Fluorine has how many protons? And again, protons are equal to the number of electrons in a neutral atom, which is given to you from the atomic numbers. The atomic number of fluorine is 9, so I'm going to put a 9 in there. Superb. Silver has how many electrons? Let's look at silver. Silver, atomic number 47. I'm going to go for 47 electrons. Sounds like a lot. Good show. Which of the elements shown has the greatest density? I see 0.5, 10.5, 1.7. As you might expect, silver, with its greater mass, has also a greater density. So, which one? Ag, silver. Impressive. The most common ion charge of fluorine is, fluorine actually only has one shown here, 1 minus. Should be acceptable either way. Hopefully on the computer I've made it that way, but wow. So moving right along. The elements that form ions with a positive charge are found on the left side and in the middle of the periodic table. By the way, you should have this sheet, subatomic particles. Part of 7.3 is assuming you've already done this back in 7.2. So that happens to be true. Metals are found on the left side and in the middle of the periodic table. So just in case you missed the point of these two questions, elements that tend to form ions with a positive charge happen to be metals. Metals are on the left side and transition metals in the middle. That is true. The elements that form ions with a negative charge, on the other hand, are found on the right side of the periodic table. So these would be things like the halogens, chlorine, bromine. The nonmetals are found on the upper left or right? Right. Right. Good. Moving right along. These are 3 resources, by the way, that are useful from your Science Probe 9 website. You need a password to get in there. The little red box here, if you put the initials of your school and you click submit, you will get the username and password. I do believe that link from the Nelson textbook is now changed. If you need the proper link, you'll find it on the website and or your course outline, or hey, see me. Anyhow, it's useful to go to these sites because they are the people that wrote your textbook. They've got a lot of lovely little practice quizzes, videos, etc. All wonderful things that'll help you master content. Anyhow, moving right along. An element has 12 protons and 10 electrons. Wow. Is the element an ion or an atom? If it has 12 protons and 10 electrons, then it has to be an ion. And the reason is that if it's an atom, the number of protons and the number of electrons are going to be equal. So this is an ion. Sure. Notice this lovely little warning. This would be what we might call a very important page. If you're confused by anything on it, hey, we should talk. So, if it has 12 protons and 10 electrons, which element would it be? Okay, 12 protons, that's the atomic number. So you just look on your periodic table. Pardon me for turning around and looking at the periodic table, but atomic number 12 is magnesium. And usually symbols will be fine for these. Excellent. 12 protons makes it magnesium. Okay, the last part of this question, what charge, if any, does it have? We're talking about its ionic charge. The fact that it had 12 protons but only 10 electrons, and it should have, if it's a neutral atom, 12 electrons, means to me that it's lost 2 electrons, right? Electrons are negative. If you lose 2 electrons, the charge is going to be 2 plus. Wow. Magnesium tends to lose 2 electrons, thus forming a positive ion, which, by the way, is called a cation. A negative ion is called an anion. Yeah, this information, by the way, you could get just directly off your periodic table, but it honestly is better for you just to think about it. These would be equal if it was neutral. The fact that they're not equal, you can tell how many electrons have been either gained or lost. Okay, I'm thinking the rest of this, you should be, just based on the previous page, be able to figure out what the answers are. If you need any help, talk to some of your lab partners, talk to me. And then finally, the last page and a certificate. Bobby can do much better than that, and so can you.